So moving forward, let's take up the next question, that is question number 11. A die is thrown 2 times and the sum of the scores appearing on the die is observed to be a multiple of 4. So sum of the two numbers, it is a multiple of 4. Then the conditional probability that the score 4 has appeared at least once. Simple question from probability. Let's see what is the sample space. We can see 1, 3, 3, 1, 2, 2, 2, 6, 6, 2. Obviously the reverse can also be taken. When you have 3, it would be 3, 5 and 5, 3. Moving forward, you can take 4, 4 and 6, 6. So total we find 9 such cases. Now let's read the question again. It says, find the conditional probability that the score 4 has appeared at least once. When you look at these 9 cases, you observe it is actually exactly once. So what is the required probability of getting at least 1 4? This is clearly 1 by 9. Now look at the given options. 1 by 9, that is option number 4 is the correct choice. So let's mark and mention as the required result. So I'm sure this is clear. Time to take up the next one, that is question number 12. If the number of integral terms in the expansion of this one is exactly 33, then the least value of n is. We have to talk about the least value of n. General term, that is tr plus 1, is equal to ncr 3 raised to the power half whole to the power n minus r 5 raised to the power 1 by 8 whole to the power r. Now for this one to be an integer, what we require, this power should be an integer, not fractional. That means r is a multiple of 8. 0, 8, 16, 24, etc. As well as n minus r is a multiple of 2. We will talk about it later. Let's first find out this one. So here we observe exactly 33 terms are given. So the last value can be 0 plus 8 into 32, that is 256. Now question is saying the least value. Obviously when you have taken r as a multiple of 8 and you say n is 256, then definitely you will be getting the result as the least value. So the correct answer for this question is 256, that is option number 3. So let's mark and mention as the required result. Time to take up the next question from this paper. A hyperbola having the transverse axis of length √2 has the same foci as that of the given ellipse. Then this hyperbola does not pass through which of the following points? Let's check out. First talk about the ellipse. X square upon 4 plus y square upon 3 is equal to 1. We are talking about foci. So eccentricity is root of 1 minus 3 by 4, that is half. Therefore we have foci as plus minus 1 comma 0, because a is 2, e is half. So plus minus 1 comma 0. Now hyperbola also has the same foci. That means for hyperbola you can say a dash e dash is also 1. This part is clear now. Now what the question is talking about, it is saying length of transverse axis is √2. That means 2a dash is √2. So a dash is 1 by √2. A dash is 1 by √2. Put it here. Therefore e dash is √2. When e dash is √2, we are talking about rectangular hyperbola, and rectangular hyperbola meaning a is equal to b. So yes, this is equal to b dash as well, because we are talking about rectangular hyperbola. So the equation obtained is x square minus y square is equal to 1 by 2. This is the required equation for the hyperbola. Now we have obtained equation of hyperbola. Question is saying from the given points which is not lying on it. When you put these points one by one, you can clearly see when you are substituting point number 2, this gives you 3 by 2 minus 1 by 2 is equal to 1, not equal to half. So correct answer for this question is option number 2. It is not lying on this hyperbola. So I'm sure this question, that is question number 13, is also clear. Let's take up the next one, that is question number 14.